Assalamualaikum warahmatullahi wabarakatuh. Welcome to Statistics Study Program Special Podcast, the show that talk the recent issues in statistics and technology. I am Arum Primandari, and today we are talking about advanced machine learning for big data analytics with Dr. Shafaatul Nur binti Hasan. Yeah, I know maybe it will be a tough topic, but make sure that you listen all the way through to broaden your knowledge. So now it's time to welcome Dr. Shafaatul Nur to our podcast. Please allow me to call you by your nickname, Dr. Sasa. She's here to provide expertise by answering our curiosity in big data analytics. Hi, Dr. Sasa. Thank you for joining us today. Today's episode is brought to you by Global Engagement Grant 2022 Universitas Islam Indonesia. Back again to Dr. Sasha. This is a short bio about her. She is the senior lecturer at School of Computing, Faculty of Engineering, University Technology Malaysia. She works in many research and publications related to machine learning, deep learning, image detection, classification, neural network, artificial intelligence, and of course, big data analytics. So, we will talk about this topic, artificial intelligence, data mining, machine learning, and big data analytics, and of course, more about the tools. Okay, so let's dig into our topic. This is the short overview from Dr. Sasa. The challenge of the also called automatically machine era is to tackle big data problem in terms of processing and predictive analytics. And by the way, in the data science scope, we often hear about like a job regarding business intelligence, or we call it BI, or any software said that they support about BI. So my question is there any connection between business intelligence, BI, with data mining or machine learning and big data analytics?
Okay. So this is a question for me.
Yes.
Because I thought it is after the speaker session. Yeah, of course, there is a correlation between that. So business intelligence for the basically the term is based on the extraction of the information, the useful information for the business solution. Okay. So at the beginning of time, so we have deal more with the industry's perspective, the business solutions and so on. So that's why the terms come out as business intelligence, and it's also related to the data mining. Okay, so data mining, so we need to extract the information that from the database, because previously we have the structural databases, right? DBMS, database management system. So we need to mine or extract the information as well. So it's based on the database. That's why there comes the terms of data mining. And lately we have buzzword of the machine learning. This is not new, but it's just used because the industry is getting bigger, and data is growth is become exponentially. So we need this kind of algorithms and tools of the machine learning, how to extract and whatever in the data science and also big data analytics related to that. So we will discuss in this talk. So basically, yes, there is a correlation between business intelligence, data mining, machine learning, big data, and also analytics.
Okay, so you mean that after we extract the data, after we analyze the data, we can interpret the data into a business intelligence, something like that?
Business intelligence is like a term of tools.
Okay.
Yeah, it's like tools. Like, but the big in the academic world, we call it under data mining. So under data mining, and it can be and the advancement of that is machine learning. Okay. So business intelligence is like a method of the extraction, or to extract the useful of information. Why it's called business? Because it's for the business decision making. Okay, so specific applications most narrow down to the business perspective. But for data mining, machine learning is we can means that we can extract the information or do the applications in various
area.
Yeah. So it's just a
Specific.
term. It's have correlation between that.
Okay, so it is similar with data mining, but it's like a specific scope in business like that.
Yes. It's subset to the data mining.
Okay, frankly speaking, when you want to analyze what so-called the big data, we require an advanced software such as like HPC, like high performance computing. And I hear about the general purpose graphic processing unit, GPU. So the next question is about what is the general purpose of graphic processing unit or GPU?
Okay, so the GPU is called that general purpose graphic processing unit. So normally this hardware will have in our computers nowadays, right? Because the gamers, the games technologies are there. Okay, but people don't know what is the purpose of that, other than gaming purpose, right? So that's why it's called GPU, the general purpose. So general purpose can be any applications that we utilize the hardware. So not in terms of the graphic itself. So we utilize the hardware in terms of the speed, the processing, the number of cores, and so on. So it depends on your hardware. So if you have so specifically this term is given by the hardware like company NVIDIA. So normally there are various research doing these applications, and not only gaming is the technology application is very that we can see more, right? But for GPU, the general purpose we can do in sciences, physics, chemistry, biologies, and also in our nowadays any applications in financial. So the application is very in various perspectives. So it depends on how you use and utilize the GPU, the graphic processor.
What is the basic difference about this GPU with CPU? Like we have the central processing unit. What about the general purpose of graphic processing unit? What is the basic difference?
Okay, good question. So, okay, what we have in our PC. So nowadays, most of the PCs we have GPU, right? Right. I hope
we have sticker on it.
Yeah, but you don't know inside it, right?
Yes.
But okay, basically we still use CPU, right? CPU, right? Very CPU processors, right? Intel, the very famous one, Intel, AMD, something like that. So they have a cores, the block of processing that want to process our data or so on. Okay. So let's say I have Intel of Intel Celeron or sorry, Intel what is it? Pentium 3 or Intel now is what 7
i7
right?
like,
yes, yeah,
i7.
So they have a course. Let's say you Intel i5, so you have maybe hexacores, hexacores, octacores, something. Application that we open the Words document, we do, and then we open the video, right? We open the WhatsApp, we open various applications and needs that CPU to optimize our works as well, with the specific course, with the parallel course. Okay, so for GPU, very normal means that GPU, very normal that we have. I think I'm not sure mine probably have 48 cores. So means that if we can utilize that, so it's very huge. It's not only a normal computer. We have one computer with octa-cores, right? They say the big cores, octa-cores, hexa-cores. We need to buy i7, something like that, to get the bigger cores. But in GPU, if you utilize it, you can utilize 48. They say, I think minimum is 48 cores. If you have more RAMs, and then you can or more specification of the GPU, then you get 96 cores. 96 cores. So you can times how many computers you have with only utilize of that cost in one particular laptop or particular PC. So we still need CPU and of course GPU to maximize our performance in the parallel.
So in the daily use, we can use CPU, and when we want to big data analytics, we can switch it into GPU, something like this.
Yeah. Nowadays, we have many tools that integrate with the GPU itself. No need to hardcore to develop or to do the library and so on. So we just can use that. We means that when we do the complex processing, so you can utilize the GPU and also of course the CPU still need to process the output for the particular application.
For the next question is about the application itself. Like when we have this GPU, the significant impact on the big data analytics is for like analyze or anything else. Or analyze the big data or anything else. Like you can when you have like a computer, you can use this GPU as your computer become a warehouse, something like that, or just when you have like GPU, then your computer able to analyze big data.
It's a good question because for normal people that means that utilize not most of the gamers will utilize the GPU in terms of graphic, right? You want the graphic right, HD, something like that. So we need GPU, the kind of good GPU. Also we have Intel graphics, right? They have their own GPU. But if you use any other type of GPU like NVIDIA and so on, it has different specification. So if you want more on graphics, so you get the nice view, the speed up of the process and so on. But for big data analytics, why we need GPU right now to utilize the GPUs? Because there are big data challenges, how to process the big data. So with the normal or traditional CPU, so we need a few numbers of big high-speed computing, right? Means that we need good servers and so on. So if you can utilize this GPU, so you no need more. You can have an in-house at very limited. Maybe you have maybe need one or two. Depends on the applications that you run. So you can optimize the hardware, and also you get the high performance if you use for the big data, especially for the big data analytics, because we deal with the challenges of the pre-processing, data processing, and also the speed, the computation.
So what about if I don't have GPU in my laptop or my computer? So what should I do? Can I run in the cloud cloud computing or cloud technology, or
Sure.
I need to go to the lab when I can work with the CPU in their computer?
Okay, again, good question. Because this is if you don't have any hardware, so you can go for the cloud. So you can probably use the free from Google. You can do data processing using cloud, Google Colab or something like that. Google Colab. Then you can utilize if you have GPU or you don't have GPU, you can use their GPUs in the cloud. If you want more processing, means that it take a few days, so better you purchase the some you need to pay monthly. Of course, there are some fees for the cloud, like something like that, cloud. If you want to utilize that, right?
Right.
So you need of course programming skills there to do how to utilize the GPU. But you ask cloud, and also you also if business people, they like to use tools, right? The cloud tools. There's open, not open source, but for academics purpose, and some of in-house company they use open source technology. But for some of the big players of the company, they use the applications that or the softwares that like IBM. So they also have many things in clouds. Azure, and they have InfoSight, and many things that can utilize. Okay, for Microsoft, they have cloud Azure. For IBM, they have.
I'm not sure about IBM.
Yeah, IBM they have because that's for the standard company, right? Most of the big players, right? And for, of course, for academician, we will try running. That's why I'm not promoting, but for me itself, I use Google Colab if I want to use more or other GPUs in mind. So I prefer Google Colab.
It's good. It's easy to share too. When we use Google Colab, it's easy to share.
Yeah.
So the next question is about the skill. So what is the skill to develop the application using GPU?
Okay, so for skill, of course, this you need programming skills. You need basic C, because based on the basic C programming, so you can for the hardware we have special, especially for CUDA. Especially for GPU, NVIDIA GPU. So they so-called CUDA programming, computer unified. Computer unified, the programming. It's called CUDA. So you need to know how to program in CUDA, and then you start with the small applications, the mathematics applications like the factorial and so on. You can start with that, and then for machine learning, of course, you need if you want to apply in the data science perspective, right? You need to know machine learning, right? You know how to at least the skills of data science that you have, and then you can go for the various applications. Like if you want to use just for the graphics, like for the games or virtual reality, so you can definitely use that in the form of the different forms, but you can utilize the graphics part, right? But if you want to use in the big data applications, so the skills must be you must have also Python or the language, high level language, not only C. C is for basic CUDA, but if you want more development on the analytics part, so you need data science, right, knowledge, skills, and also other high-level language are Python and so on, because this one you want to utilize under the language, the GPU under that specific language. So it depends. For me, if you have multiple skills, it's good. If you just want to start at how to utilize this GPU, you can try CUDA. Okay.
Okay. So we as statistician is only know about like R language and Python language. The CUDA is really new, and we don't know yet about the C. So how to start to know about this CUDA language?
Yeah, of course you need to have some.
What is the basic language, Doctor? I mean that we already know about like R language and Python language, but this CUDA is very new to us. How to what's the basic requirement to know about CUDA?
Nowadays we have Python CUDA as well. So if you are very good in Python, so you can also utilize Python CUDA. And maybe later we will have some courses if you really interested on the CUDA. Probably we can have some on that. So it's good. But if you want to start with the language that you know, right? So maybe you can start with Python. There's Python CUDA. The basic of the CUDA is C. That is very basic C. No need to know the parallel computing and so on. At the first time in 2010 when I started to learn about CUDA, at that time we saw not many references like nowadays. Okay, so we invite the Microsoft team, the NVIDIA from Singapore, to teach us. I think about that, but it's not easy at that time. But when we already digest it in maybe in a particular way, and Alhamdulillah we get some knowledge of that, and we can say that this no need too complicated language, just C language that you must know. And then some skeptical, they said that you need to know the parallel computing and so on. Of course we don't know at that time because there's not many skills. Although in computer science there are not many skills on the parallel computing as well. Okay, so after we know CUDA and I know how the process, alhamdulillah, that's why we come up some for our own module for that. So to understand, because based on our experience how to understand, so now we simplify it.
It is about the architecture of the computer, like you said, the parallel computer like this. The CUDA is for the language for the architecture, the computing architecture, or about the how to analyze some data. I mean.
Okay. So GPU itself, if you using CUDA, okay. So you can do anything with that. It's like a normal programming. Right? If you have that's why if you have skills of data science, you can make it as a data analytics applications and so on. You can apply in the analytics. But if you have a skill on the virtual reality, you have skill on gaming, they develop gaming in-house applications, so you can utilize the graphics itself, just the graphic part. Okay, if you have image, if you want to just display the image, like the satellite images, something like that, so you just no need to program the GPU, because you just want to have a nice right. So means that we still use human, right, expert to analyze from the satellite images. There are some specialists on that, because some of our applications still use human, right, for the observation. So you utilize only the graphic part. But if you want to do analytics more, so you utilize the programming part, right? You can use, that's why the CUDA, simple CUDA, starting from simple CUDA, running the very simple application until to the complex applications like we have analytics, big data analytics and so on. So it's just a new paradigm of programming. It's high level of the C programming. Like we have Python, right? We can do machine learning as well, Python, and we can do normal statistics. We can do the maths, right? Something like that. But we utilize the differences. We utilize the hardware.
So it's complex language atau?
It's because we need to have communication between CPU and CPU.
Okay. So the next question is about the library itself. In how to apply, or maybe I will start with, is there any machine learning library in CUDA, like you said? Like we have Python and we have like TensorFlow. Is it also applied in CUDA or in GPGPU?
Okay. So the programming, the basic programming is the CUDA, right? So the hardware is the GPU.
Okay, so hardware is GPU and the software itself on the language is CUDA.
Yeah.
Like that.
So
okay.
if you run using Python, TensorFlow, behind that they use CUDA and also you utilize the GPU.
Oh.
Okay. So we have like Python, they have library, right? Let's say you want to run machine learning, you call the scikit-learn, right? Scikit-learn.
Yes.
Scikit-learn.
Yes.
Right? Scikit-learn. Okay. So this from the machine learning scikit-learn, and you call the GPU, something like that. So you call the GPU. From there you have specific how to call that in Python. Then you utilize the GPU during the processing as well. So you behind that is a CUDA, and also you also utilize the GPU under the Python language, Python CUDA language. So behind that we don't know, because of course we are the user, right? We don't know the dev part unless we want to develop.
So actually maybe the bridge is we know about like Python CUDA and CUDA itself. Can we?
Yeah, you can start with CUDA itself and then you utilize Python. And then you can do some applications, or you can directly use like TensorFlow. It's directly used when you run the image processing, right? Then you want to apply GPU, yes or no, then finish. So they do it for you. Yeah.
Okay.
So we have different kinds of users, right? We have researcher, we have developer, we have the normal like industries. They just want a solution. They don't want to know what is behind that. But we as a researcher, normally we know everything, or we need to know everything because we develop in that as well. Okay, but it's good for you guys to know what is the basis for of course for the startup company that they want to use for the in-house, right? So they need to know this technology behind, right?
Okay, so next question is about when we have the skill, actually, like how to join any participant in the development and in GPUIM library. I think this is the library, right?
Yeah, this is a library that we developed together with the University of in Portugal, Polytechnic de Guarda. So Professor Noel is the head of that this library. He's actually doing this for a long time since his PhD work. So we collaborate with them with this particular professor, Like a Python that you asked that, right? We have TensorFlow and TensorFlow and so on. So we develop on top of that as well. On top of that we use CUDA, and then based on the C++, we also develop some libraries to use. So we have varieties of libraries that you can use on top of the GPU. So this library is so-called GPU MLib, GPU Machine Learning Library. So there are many machine learning algorithms there that have been utilized in many applications, various applications, utilizing the GPU, especially in the machine learning.
So, how to use this GPU-M library, Doctor? I mean, like when I
you can freely download because it is open source. So I will show you in the
yes, maybe in the workshop like something.
Maybe inshallah we will have a workshop together again, maybe last time like 6 years back, right? So yeah, and hopefully I will be there as well.
Yes, hopefully.
Not only virtual, and let's make dua that this pandemic will be erased from the world and like that. Okay, again, to join, to participate is very easy. So you can have a collaboration as well. Means that we have post collaboration if you want to do the master's PhD program. So you can have a joint venture of the projects and so on. So and then we can have, of course, when you have the knowledge on the CUDA and machine learning, data science, and so on, if you're interested in the development, so you can join us anytime. Not only as a collaborator, you can just as a researcher, right? Or as anyone, because this is open source, so we can just apply whatever that we have developed, or you can be a part of our the developer. Okay. So the good part in this machine learning library, because if you can see, most of there are many tools provided, machine learning tools, like the very famous is of course the Google, that they have with Python libraries and so on, right?
Yes.
Machine learning. Yes. But most some of they also have limited on the machine learning libraries itself, the machine learning algorithms. So we have various kind of machine learning algorithms inside and there is also many things that we are not venture yet. So many things that we can do together if you really like to join us in this kind of the. Actually, we have a big idea or features for this, but of course we need a community support as well. Of course, we need a very good skills, right? Very good skills in terms of machine learning, data science, and then the programming skills like Python and there are many things that we can do together. I think it's not only for computer science people. I really like to have the community from others, like statisticians, right? Mathematicians. I think I believe that you can do more than that. Just the skills, the knowledge to upgrade, right? So that's the beauty of machine learning and this library, but it's still under development, some of the algorithms, right?
So to make it clear, because I am a statistician and I'm not familiar with computer architecture, what we talked earlier is about the GPU, which is hardware, and the GPU is using CUDA language. This is the language. And then this also have the library called the GPUM library, something like that. So we can use this GPUM library by only downloading it because it is like open source. But how to use it? I mean, after we download it, how to open it?
Okay.
Like,
so can I share some screen?
okay.
If I can share, I can show you how you went to
Okay,
download.
I will
How it
use
looks like.
share the screen. I think it is good enough that you can show because I myself still confused about this concept because I do not have knowledge about the computer architecture.
I know, that's why I propose this title. I know that this is quite new for the others than computer science. Computer science as well have difficulties with that if they are not really into this particular studies of the big data, computing parts and processing. So no, this is not for people that in computer science itself. So we open to various research and particular, not only particular for computer science. So that's why I like to have many the merrier, right? The more the merrier.
The many, the more, yes, the more the
research
merrier.
area. Yeah.
Okay, Dr. Sasha, can you try again to share your screen?
Okay, I try to share. Now we can see. Okay, I have some.
Yes. Already, I can see the screen already.
Okay, maybe I show you what is the GPU MDIP. Alright. So okay, I start with the how GPU. This is the question, right? Because I think people still wants to know what is the GPU and how to accelerate this big data analytics. Some kind of problems. Okay, so this is we have like this is 6 cores, something like that. So this is if we run any science applications. So this is CPU, we have 6 cores, and this is GPU. If we run in one Tesla, we have 1000 and I think 1048. Not the latest Tesla. So 1000 of the cores we utilize in one single server, something like that. If normal computer, like 48 cores, 96 cores, right? So we have these two that we want to accelerate the applications, right? So we have also the CPU code in the side of. We also need the code in the CPU. That's why we need C, basic C, or Python, and then we have the GPU part to parallelize the GPU using the CUDA language. Okay, so we need to interact between the CPU, the host, and also the GPU, this device. So it's like a computing device computing as well. It's likely in engineering part as well. The architecture behind it. So okay, again, this is just a comparison for the if you use the very, I think now they have many updated Teslas. So this is previous Teslas K20. Okay, over there, this is I think what put at that time the Sandy Bridge CPUs, and this is it's like a data center, right? It just use CPUs. So you can utilize how many you can. So if this is scientific applications that I say that you can do in engineering, right? You can use MATLAB FFT if you utilize the library of MATLAB FFT for the engineering applications, and then physics if you run COMA, and sciences, molecular dynamics, you use Ember, something like that. If you utilize GPUs, so it can be up to 20 times and more. I think now it's more. Okay. Okay. So this is just why this computing performance matters. So besides we utilize the CPU for the processing, for the speed up of the performance speed up. So we also utilize the computing performance for in terms of watt. So let's say you run the 7 megawatts. So 7 megawatts for 2.3 petaflops. It's like a 7,000 homes, right? That's 7,000 homes, 7 megawatts. If you utilize, means that you can 5 times energy save the energy efficiency. Okay, so if you optimize doing the so many tasks in the parallel, so this is rather than you use the optimize the serial task of the CPU. Okay. Traditional CPUs are not academically feasible, and now the era of GPU accelerated computing is nowadays today's. So this is the problem. I believe that there are many updated Teslas nowadays. Okay, so what we have used previously, also Tesla. Okay, so this is the comparison if you run in the normal server. I think it's normal server, but it's quite a good performance using Xeon, Intel Xeon and so on. Okay, okay, this is the comparison. So we can have 8 times faster and 6 times faster than this of kind of applications. Okay, 90% faster if you use Tesla with PSA Xeon 5, 60% faster and so on. Right. And of course, nowadays we have the deep learning, right? Deep learning training. So in less than days, okay. So if you use now, we have a Tesla V1000, Tesla P100, okay. So it's the time to solution hour is lower, right? This kind of because you know that deep learning we have more training, right? And it takes time. Right. Okay. So means that one GPU node can replace up to 54 CPU nodes. Okay, for the high performance computing. So this is the example for the life science, physics, and also geoscience. Because not only doing the analytics, we have many other high performance computing, right? For various applications, and then based on this, if you can imagine, we have 640 tensor cores in the Tesla, right? So okay, and have the 100 teraflops very optimum performance. Okay, so it's give the 47 times higher throughput than CPU server deep learning inference. Okay, so yeah, 47 times. So you can imagine you have if normally you use CPU in 3 days or in a week, so maybe it can be in 1 or 2 days only, right? The kind of application. Okay, so this is the what we have advancement. We not only have the machine learning algorithms there, also we have the advancement of the machine algorithm. So particularly for this is not for only for normal data, also for big data. So that's why we propose the using this under the platform of the GPU machine learning library. So so you can download here. So the question is where we want to download, right?
Right.
So you can type. I'm not sure this. When we go to GPU-MLib, so this source. Okay, this is open source library. You can download, right? Okay, so this is the latest development 0.35. So if the Windows setup, so then you can directly download. Right, so we have the features of it. So this is all the algorithms, the components inside this library. Okay, particularly in the machine learning algorithms. Okay, so we have backpropagation. Yeah, So we have the advancement of the backpropagation algorithm. We have the small multiple propagation, and then we have also non-negative NMF factorization. We have semi-supervised NMF. This is the advancement of the NMF. And then we have also this autonomous ATS, automated. It's like a deep learning nowadays, but this is developed ways back in 2006-7. It's creating BP and MVP networks, multiple backprop, the advancement of that using the autonomous learning system. Right. In deep learning, we also have auto encoding, right? But this one is developed, I think, previous ways back, but it's still good to use. And then neural selective input model also advancement from the BP and also from the BP. And then this is particular for the application for the to handle the missing values, right? So you have many problems, right, for the data, how you want to curate the data, pre-process the data, and so on. So some of the models is allow that network, particular network to handle missing values. And then we have RBM machine. Also, we have some of the deep learning algorithms as well, deep belief networks. Of course, the BP and this MVP is already applied in deep learning algorithms as well. And SVM, the machine and others of machine learning algorithm. Okay, so they have RBF and so on. But in our part is we particularly contribute to this kind of the advancement of self-organizing map. So we do these two parts, and also the advancements of self-organizing map using the multiple type of SOM with the application of the surface reconstruction. Okay, so you can have a model of the face, face or any model that you want to reconstruct, any graphic features. So this is what our conclusion, not only for this particular algorithms, but also for the enhancement of this for the particular application. Okay, so this is our publications. If you want to know more, or you want how you want to apply, so there are various of applications have been done this library,
using this library.
Yeah, so you can refer to our papers as well. Right.
Okay. Thank you, Dr. Tasa, to share about it.
Okay, so is it explained to you how to download?
Yes.
Yeah.
Yes, I mean, it is I just curious about the library, because yes, I know it's about the Python, and when I have Python, I can use like TensorFlow library from Google. So when I have this hardware like this GPU put on my laptop, then maybe I need to little know about this CUDA language, and then how to work this CUDA to speed up the processing of big data analytics, especially when I work with machine learning. Then I can use that library too, right?
Yeah, good. That's because we want the research work that also benchmarking with the others libraries as well.
So it is like the alternative for TensorFlow, something like this. That we can maybe sometimes we use TensorFlow, sometimes we can use this GPUM library, or
yes,
some like the alternative.
Yeah, it's depends on what applications and what algorithms. If deep learning, we also in the GPM we also have deep learning algorithms, and also you can customize, right? You can customize if you using is not only you can just apply, but you can also do on your own the proposed methods and so on for your own goods. For the I believe that for specific applications we need specific algorithms or the altered the updated existing algorithms to suit with the particular specific application, right? So this is the opportunity because it is open source. Right?
Okay, let's wrap up with Dr. Sasha. I think it is, yes, I said before that it will be a tough topic, and yes, it is very tough for us statistics, and I can say that inside your computer there is a big search to speed up your analytics by using this GPU, and it's not only for gaming, it also like general purpose, like you can use it for big data analytics, image processing, language processing, something like this. And to know about it, you can learn about the CUDA programming. And when you already know about Python, there are also Python CUDA for you to start about the learning CUDA. And CUDA programming is basic on C language. When you know about the C language, maybe it is easier for you to learn about CUDA programming. And about the library, you can use this library as alternative, or you can put your deep learning model using this library, customizable deep learning model using this library as well. Final opinion, Dr. Sasha, for us, especially as statistician or mathematician, because we all know it's about the modeling. We don't know much about the architecture. Any opinion for you or any suggestion for you from you for us?
Okay, better late than never. That's why. Better late than never. I think there's no such things that you still don't know something like this. Okay, it's good to know now, and then you can have an overview, and then you can start to do to plan with the students and so on, because this will be evergreen. I believe will be evergreen, and not for us, for our futures, for our child and so on, right? So better late than never. So you can start now, find the skills related, right? And then if you want just to try the application, so you can just go to the GPM link, then you can run. They have a demo. If I can show here, I'm not sure. I prepare for that. If you want to know, if you want to see what you can.
I think it's okay. We record this podcast,
so you can directly use this software.
I think it is okay for you to share screen once more time.
Wait, maybe I should. Can you see my window?
Do you use Windows OS or Linux?
Windows. Can you see my screen?
Yes.
Now you see what in the back. So you can see this, the GPM.
Yes.
Yeah. So it's simple as that. You type in the CMD. Because this one, this is the GUI that we have developed for normal users. That if you don't want to know what is the behind that, so you want to test, but of course you need to run it in your PC, so you can just call this in the command prompt of this. So you can run it from after you download. So you have a folder, and then you have execution file. The execution file you need to run it in order to open this GUI. So this is one of the example of the interface that we have developed, right? And also present this. We are invited in Silicon Valley for the GPU technology conference in 2018 in San Jose, US. So we present this and we call from our server back to previous big data center. So we have we utilize the GPU in the server. So we call this GPU mlib for this specifically for the application interface reconstruction. So let's say you have we start with the training data set. Okay, so here I have in my computer. So you need to have in the apply. So we have many. Let's say this is a graphic in a graphic data. So we have sphere, right? You know the sphere. How it looks like. It's like a ball, right? So this is how to utilize this one to see. So this is my device. It's automatically detect my device. Yeah, the GPU part. And also, if you don't have GPU, you can just put CPU, or it will automatically detect only CPU that you can. So at this time, I will run in GPU. Okay. So let's say I have this is just make a default parameters for this. Let's say I run in this sphere. This is in the cloud points. This is in graphic part, the graphic processing. So I will train. So you can see that because here I only put 10 iterations, so you should be more because of this is just a demo and have small time, the number of time, right? So the sphere is not really constructed well because it's not have many iterations or many trainings. Okay, so because of this is just okay. So this is the detail what is behind that we have run. So under this is on my GPU right now in my PC. Previously we run in US. We utilize our server from our server in Malaysia from US. We call it our server in Big Data Center. So we run Tesla, okay? We run Tesla, and but at that time put many iterations. So, but just 10 iterations you can have on only 0.115 seconds.
Not even 1 second.
Yeah, not even 1 second for 10 iterations. Let's say we try more iterations, right? Or you can have different parameters, but here maybe you can try in 100 iterations. You can see how is the performance, right? It's better, right, than previous. Okay, so the sphere is going to reconstruct. This is based on the mesh or the cloud points. The data set is on the mesh of cloud points, and how we want to construct. So it's not limited to only the object, right? So you can construct any object, including the face. Right? Okay, so let's say here for 100 epoch or 100 times of iterations, we only have 1 second. So you can have more. So you utilize only your GPU, normal GPU, right? And how about if I'll just run, I don't know, what is the difference? If let's say I just run using CPU, is it okay? So yes, you can. So you just use this, you select CPU, and then you train.
It's okay.
Uh,
Yes, it's slow. It's slower.
Yeah. So you can have a kind of output is a light, right? It's likely like previous in GPU, but in terms of training time, okay. So you have more training times, right? Maybe 1 second if you run in the GPU. So sometimes in CPU is less, and sometimes in GPU is more. So if you run a very small data,
Gotcha.
so you can just use CPU. You need to utilize the GPU because why? It will take more time to transfer the data from the CPU to GPU, from GPU to CPU. So
The transformation.
yeah, because we utilize the hardware, right? We have more communication between the hardwares. So if you have the that's why the application is more for the complex and also big data applications. Not only big data, when we say large data up to big data applications. So that's why GPU will be very conducive to apply. So let's say you have 1,000 of training, so you can see the difference between of CPU and the GPU itself, right? Or 500 iterations in 500. Let's say in 500 iterations, if you use this kind of this GPU, so how many times that you will spend okay. So I think this is better than previously because we will update the number of training, right? So you have around, this is will save inside your folder that you download, okay? So don't worry, you can refer to that and you can make the comparison later, okay? So this for 500 iterations use 4.874 seconds. If let's say you use the GPU, CPU. So you can use the default application. Then if you want to know more about the parameter, so you can refer to this work, the publications and so on. Okay, so you can compare. Okay, so now you have CPU.
Faster.
Okay, so this is training time for 5 because we have
500.
okay, okay. So because of this stack, this is GPU.
I think maybe it is too little too. Like,
Yeah. So
500 is not a big deal.
Yeah. So is for CPU is still lower than GPU. Just utilize the 500 iteration and so on. So this is very interesting because not every time we will use GPU, right? So that's why it's very if you have complex and bigger data or large data, so you can see the comparison in terms of the CPU time and also GPU time. But if you just run whatever tools that you use, you don't know actually is it compulsory we use GPU, or that's not compulsory. Means that you can just utilize your CPU, you need the GPU for some of the data. Okay, it depends on the size of data and also the complexity and also what algorithm that you use. Okay, so this kind of problem still feasible to use the CPU, right? So we have less than maybe 1 second, right? For CPU, but for GPU it takes time, 1 second. For 4 seconds for this because we have two maps here. The behind of this we have two layers, right? So that's why we use dual layer. This is the advancement of this self-organizing map, particularly for this surface reconstruction. So that's why we have two times here. First layer we have 4.8 seconds. Second and second layer is 1.03. Okay.
So it is like user friendly. I mean, I do not type any code in the GPU
So
MI.
for the end user that no need to have any knowledge on this particular background of the you can just use the implementation. So this is some of implementation. Other than that, so you can use this self-organizing map for the clustering, right, and classification problems, any classification problems. And then you this is previously that what I demo surface reconstruction. So this is I think is the autonomous training system that utilize the BP multiple backprop, the advancement of the backprop. So you can utilize, and then for non-metric factorization, I use this on the data set with the collaboration with the universities in Egypt. So we have the data to differentiate between the base of courses, yeah, because courses in Arabic country is very expensive, so they want to know what is the it's called the breed, the expensive breed based on the features. So we use this non-metric factorization in order to train in order to select the features, the best features, and then we use other libraries like ATS and SOM for the machine learning part, for the analytics part, for the classification part, and so on. Okay, so you can utilize as many as you want, all the algorithms. So only one algorithms you can do, right? Okay.
For us like Apple user, is it I think that the Apple is not provide GPU, am I right? Or maybe they have.
Oh, this one you can also Linux. You can also, I think in you can also download Linux operating system. Apple, I'm not sure. Mac.
Mac user, we cannot use it.
Previous library. So you use Apple?
Yes, I use Apple.
MacBook. Wait, I will find the GPU mlib, so you can see from the you can download the means that I believe Linux is yes, or you can or you can have multiple OS inside your
like virtual OS inside my MacBook.
Yeah, I think MacBook have application that you can also use some of the Windows application, right?
Yes, we using like VM, something like this.
Yeah. So normally my some of the participants right for the certifications they for the MacBook they will replicate the Windows.
Okay.
Well, or you can use virtual machine if you know how to set up. You can use a virtual machine. Then your virtual machine is closed, but it will utilize all your computing power, the cost of the CPU.
because the CPUs are maybe like different when we have Windows, something like this.
If you use new MacBook, I think they have new processing, right? There's not use.
Right. They are not using IBM product again. They use like M Core.
Yeah. M1.
Yes,
Yeah.
M1, something like that. Mm-hmm.
Yeah. They utilize the GPU, right? No, the battery.
Mm-hmm. Yeah. Okay, I think it's enough because it's long enough for us to chit chat. Thanks for listening to the Statistics Study Programs special podcast with Dr. Sasha. Maybe in the next occasion we should have like a workshop, Dr. Sasha, to know more about this GPU-M lib because it's just like a short, or it's just like you give us a glimpse about it, and it's kind of interesting.
Yeah, it's okay.
Thanks once again, Dr. Sasha. And before we go, some love by leaving comments and thumbs up. And stay tuned for the next podcast. Wassalamualaikum warahmatullahi wabarakatuh.